Okay, so what do we do when we deal with fractions that do not have a common denominator? Okay, so we're going to be today talking about rational expressions, but again, we want to work back and look at some examples from when we were younger. Okay, so let's say that I had 1/4 plus 2/3. Okay, so I'm trying to add 1/4 and 2/3 together. Well, again, the way I mentioned to you guys when you were simplifying that I think it would have been better if we taught you guys these fractions this way. The first thing we need to do is we need to break these things up into their prime factors. So we're factoring each of these numbers here. Well, 4 would split up into a 2 and a 2. Okay, and then your 2/3 would split up just into 2/3. Okay, because there's 3 as a prime number. So the question that you guys are going to ask yourself when you're doing that is, we need to make sure that the factors on the bottom all match. Okay, so if I look at this one over here to the left, I can see that it does not have a 3, and it's going to need a 3. So I could multiply this side by 3. Okay, so now if I look at my bottom, I see that this one has a 3, and I see that this one has a 3. So that's awesome. Okay, so now I'm going to look then at the other side, and I can see that this one has 2 2's, this one doesn't have any 2's. So I need to make sure that this one has a 2, and not only one 2, but it needs to have another 2 on there as well. Okay, so now I can look and see this one has a 2, and this one has a 2, this one has a second 2, and this one has a second 2. So by doing that, I have now ensured that my denominators are the exact same. Okay, and all I did was I factored, and I looked at the factors, and I made sure that they all had the exact same factors up there. Each has a 3, each has 1 2, and each has a second 2. Okay, but when I do something to the bottom of the fraction, I cannot change it. So if I do something to the bottom, I also have to make sure that I do the exact same thing to the top up here. Okay, and that's exactly what we're going to do with this problem up here. So remember, the nice thing about these monomials is that we can look at them and we can see what factors they have. So if I look at this one over here to the right, I see it's got a 2, and it's got an x, and it's got a y. Okay, well, when I look over here, I see that this one has an x squared. Okay, so x's, this has 1x, this has 2x. We're going to have to deal with that, but bottom line is they both have an x. This one over here does not have this 2 or this y. So the first thing I'm going to need to do over here is I need to multiply a y, and I need to multiply a 2. So just like I was doing down here, I can check, is everything matching up? Well, yes. Now this one has a 2, and this one has a 2. Now this one has a y, and this one has a y. Okay, so I'm just checking to make sure they all have the exact same thing. Okay, so they each have a 2, they each have a y, but the one on the left has 2 x's, like it has an x squared, an x times an x. And the one on the right only has 1x. So that means this one on the right, I need to make sure that I have that second x there. So this x squared, that's x times x, sorry, wrong color. Okay, that's x times x, and now on the right side, I have an x times an x. So I now have the exact same denominator, and I've checked that by making sure that we have a 2 and a 2, we have a y and a y, I have an x times an x and an x and an x. Okay, so my denominators are the exact same. Once I do that, I can't change anything, so I have to make sure that I do the exact same thing to the top. Okay, then if we go back down to our fraction question down here, okay, I had to make sure that I did everything the exact same. So up top, I've now got a 3 times a 1. So that gives me 3. Over, on the bottom, I have 3 times 2 times 2, which would give me 12, plus 2 times 2 times 2, which would be 8. If I multiply all 3 of these 2's together, that gives me 8. And then again on the bottom, 3 times 2 times 2 gives me 12. Okay, so these steps right here were my steps to make sure that I actually had my common denominator. Okay, and then once we have our common denominator, we know that our answer is just that same denominator, and I'm going to do 3 plus 8, which is 11. And that's my answer. Okay? So back up top then, I'm ready to go ahead and multiply these things together. So 2 times y gives me 2y squared. On the bottom, I have a 2 times y times x squared. So I could just write that 2x squared y. Plus, up top, I have a 3 times an x, which gives me 3x. And then on the bottom, we made sure we had the exact same thing. I've got my 2, I've got x times x, which I can write as x squared, and I've got my y. Okay? So do these both have the same common denominator? Yes, they do. So our answer is going to have that common denominator. Okay? And then up top, I'm just going to have 2y squared plus 3x. Now, can I add those together? No, because those are not like terms. They do not have the exact same, but that doesn't matter for our answer really. We just write our answer like this: 2y squared plus 3x over 2x squared y. Now, a lot of people will want to cancel that, but remember, once that plus sign shows up, we have to worry about killing kittens. So we cannot cancel anything right now with that plus sign in there. That's just our final answer. Okay? Let's do one more example here. Okay, if you guys go to the next slide, we've got multiple ones here. Even with multiple ones, you still have to make sure that they all have the exact same denominator. So go ahead and pause the video, try it on your own. Okay, so hopefully you've paused this and tried it on your own. Okay, now we're trying to get all these to have the exact same denominator. So when I work this out, 5a squared, 6, that's really the same as 2 times 3, and then I have a b. Okay, plus 9 over 14 is really just 2 times 7, and then I've got a times a, which is a squared, b times b, which is b squared, plus b over a. Okay, so I'm trying to make sure that they all have the exact same thing. The first thing I see is I've got a 2 and I've got a 2. That means this one over here is going to need to have a 2. Okay, I've got a 3. So this one's going to need to have a 3 here, and this one's going to need to have a 3 here. Okay, I've got a 7, so this one's going to need a 7, and this one's going to need a 7. Okay, so now I can check. All of my fractions have a 2, a 3, and a 7. Oh, I forgot to mark that 3 there. So numbers, we're all good. Okay? Now, I can look at this one over here on the left. I see it has a b. This middle one has a b squared. Okay, I cannot take away a b squared. So that means this one over here is going to need an additional b. So now I've got a b and a b. I've got a b times a b. So this one over here is going to need a b squared. Okay, and then the last one that I have, okay, I have an a squared. I don't have any a's, and then I've got one a here. So a squared, we can't take anything away, so this one's going to need an a. Okay, whoops, don't need to do it on the top yet. My bad. Okay, and then now I've got an a times an a, which is just a squared. So then this one over here is going to need an a squared. Okay, so now whatever I did to the bottom, I also am going to have to do to the top. So up top here, I'm going to have to multiply it by a 7. I'm going to need an additional b, and I'm going to need an a squared. This one here in the middle, the only thing I had to change to this one was I needed to multiply by another 3. Okay, now on this far side, I need to multiply by a 2, a 3, a 7. I need a b squared, and I need an a. Okay, now that is a lot. Okay, we got a lot of stuff going on up there, but we're all going to be okay because we're going to work through this together. Okay, so now I'm just going to rewrite these fractions, and they're all going to have the exact same denominators. Okay, so on the bottom, I've got an a squared. I've got a b times a b. So this fraction is going to have an a squared, b squared on the bottom. Then I've got 7 times 2 times 3. That's really just 7 times 6, so that's 42. Okay, and I can check on this middle fraction here as well. 7 times 2 times 3, well, that's the same thing where that's 42. a squared, b squared. Same with this one over here. A times a is a squared. I've got a b squared over here in blue. And I got 2 times 3 times 7, which is just 6 times 7, which is 42. So all of our denominators are the exact same. So we're good there. Okay? Now, up top, I've got 7 times 5, which would be 35. I've got a squared times a squared, so that's now a to the 4th, and then I've got a b. I've got 9 times 3, that is 27. I've got 2 times 3 times 7, which is 42. I've got a b times a b squared, which is b cubed, and then I have a single a, which is a. Okay? Our denominators are the exact same. So we have one simple denominator, 42a squared, b squared. Okay? And now I can just add everything together up top. And my goodness, this looks confusing. How are we going to add that? Well, guys, none of those are none of those are like terms. Okay? So we can't even really add them. We're just going to write it as 35a to the 4th b plus 27 plus 42ab cubed. And that's all the more that we can do with that one there. We got it to be a common denominator. We wrote it as a single fraction. And that's it. Okay? So we just went through a couple examples where there were monomials. Okay? And then the last video that I had for you guys, we are going to be adding them when they are going to be trinomials on the bottom. So guess what we get to do? Factor! Woo! Everybody's excited! Woo!